Okay, Jeff Ginger here from Project WHIMC, just showing through an update that we've made to our new Science Tools plugin. There have been a lot of major changes, and you're going to need a whole new configuration file to make use of it. However, it does quite a bit more now, and we've got more planned down the line. So I'm going to go ahead and open up the configuration file because that's where most of our changes have taken place, and show what all we've changed in there, and then show how you can use it in the game for new kinds of science learning interactions. So if I open up the configuration file, go all the way up to the top here. First and foremost, probably the most important and coolest thing is you can add any variable you like. If you'd like to add a variable like, say, a tectonic activity, you can just start typing it in. So I'm going to call it tectonic. I'm not actually sure if I spelled that right, but there we go, tectonic. And so now this is actually going to be turned into a command and function as a new kind of science variable. So now I still have to give it some information. We give it a display name. And this is where I would say like what it actually is. So maybe this is tectonic activity. And this would be like, is there any detectable seismic activity that is going on beneath the surface of the planet? Does it have a molten core or a solid core? Is it still active underneath? Which would impact other kinds of things like your magnetic field and so on. And related to this, you can do aliases. And aliases is where we've given, and you can give any number of aliases. So there's a couple of ways you might use this. First of all, you could say things like seismic. Again, I'm not sure if I'm spelling anything right. You can tell this is embarrassing because I don't have an autocorrect for me. Seismic. But you could also have other things like if a kid might not know how to spell, just like me, so maybe they would say tectonic. There we go. Let's say a kid decided to spell it like that. You can actually give alternative spellings. Now, this seems kind of ridiculous, and we could use something like natural speech language detection, but this is sort of a shortcut to just catch either shorthanded forms of spelling, or what we notice is honestly like kids spelling temperature. We had maybe a third of the attempts in the earlier years, in like 2018, 2019, a third of the attempts to spell temperature failed. And so this is where you can kind of make up for these common spelling errors. Now, you might want to teach the kid how to spell, but this is also a way to design an interface that's a little bit more forgiving for complicated or difficult words. If you have read the documentation for our plugin, you should be familiar with most of the settings already for a given tool. A few notable changes besides aliases. Default measurement, if it is given a numeric value, will be flagged as a numeric tool. If it's given a string value, it will be flagged as a string tool. The unit is what directly follows when you measure the tool. So if you type in /tectonic, you will get 1 and then whatever we say in unit. So on the Richter scale is how it will come out. Precision is the number of digits following the decimal point that this tool will use. So in this case, it would be like a 1.2 or 1.5. It could only do a 0.1 digit amount of distance past the decimal point. If you use precision, that also will flag it as a numeric tool. You can set this for specific worlds, and this is one of the major changes we've made, is that each specific world can have its global measurement. So like on the moon, we have it's inert, there's no molten core and no earthquakes that I know of, or at least they're very, very small. And then we have we can have region specific. So on the moon, we might have by the 3D printer. We might have a region that's called by 3D printer, and we can set that to be a specific amount. So maybe it's a very rumbly, seismic creating 3D printer, and we could set that region. Now there could be a different 3D printer on a different world and have a different value for that. So that's nice because we, for instance, have an ocean region on multiple worlds that has different effects. So now, some other examples of this, maybe you want to simulate there's an earthquake happening, but it's not always rumbling or happening all the time. And that's where we can use some of our calculation-based determinations. So if I scroll down here, we can see some examples. So we've got this random, for instance. That's one way that we could have an earthquake show up. So I'm going to go ahead and just copy that to my clipboard to make this easier for myself. So if we want to have a random earthquake show up, let's do this on, say, Earth control. Earth control. We're going to do our global measurement for Earth control. And we're going to then put this in our quotes. We can have a random, and we can make that a binary of either a 0 or a 1. And then we can multiply that by some other amount. Maybe we have, I don't know, we can do another rand actually. Let's see here, anywhere between 0 and, I don't know, 2.3. That's kind of ridiculous, but here we go. So what that's going to do is that if we get randomly a 0, there won't be an earthquake. If we get randomly a 1, then there will be an earthquake, and it'll be between these two measures. And so this is kind of fun, is that you can have your science tools be dynamic. They can be created based on other variable information. Now, this is giving you like basically a 50% chance of there being an earthquake, which is pretty ridiculous. So that might not be accurate all the time, but if we do want to emphasize these things are not always occurring, you could accomplish it by doing this. And if we scroll down, we can see some other more interesting examples. And this is one of the major differences we've made with the new plugin update is we have some new placeholders. So before you may not have known this, but we could use things like your coordinate data. So for pressure, the higher you go up in the atmosphere, the less pressure there is in the atmosphere. So we have this Y value that's reducing the amount of air pressure up there. Likewise, we've now added the placeholder for weather. That's either 0 or 1. If it is raining or storming or snowing or something, it can be that it's 1, and then you can adjust things like temperature or pressure based on that. And there's some other cool stuff here. If I can find, here we go. So here the pressure is higher the further down you go under the ocean. Likewise, under radiation, the higher up in altitude you have, we're using one variable to calculate another, that can go there. So students can try to reverse engineer this. They might figure out what's affecting this measure that they're getting. They can make some hypotheses, and this also could be a kind of a fun way for like an assignment for a student is they have to figure out how to make the variable accurate, the science variable accurate based on calculations that they're putting in here. The other one that we've added that I did not show here is nighttime. So night and day, for instance, would affect temperature, but could affect all kinds of other things like UV radiation. So one of the things that's super cool about the WHIMC Science Tools plugin is that once you've modified the configuration file, you can actually reload it live in the game. So I can type /science tools, reload, then you'll see if it's working right, it'll have all the different things that are loaded up in it that will sprawl across the text, and you should then be able to type things like tectonic, hit enter, and there we go. With the measured tectonic activity is 1.0 on the Richter scale. So we've now got that attribute ascribed to this world, which is pretty darn cool. When the Science Tools is loaded up with the server booting, it should have autocomplete available for commands that are run at that or loaded at that time. So just like /temperature, which we were saying was hard to spell, should be available along with some of the others that might be difficult for kids to figure out. Our next update, we're going to have this data actually be written to the database. The Science Tools command information is already available in the database under Core Protect within the table that includes all commands, but you have to export all commands and then thin them out to find the very specific ones. So one of the things that we're going to be adding in the future is the ability to have these commands logged, so we know not just every time a student's making an observation, but also when they're taking in any kind of science information that might be about that world. The last and final thing that we've added that is notable is if you want to make a quest with a custom objective, you can now do that directly with Science Tools. So in effect, that very first world that we have where you're learning to use these on the moon, you have to input the values into the computer, I think it's important for students to process the number and sort of understand that they're collecting some data and writing it down. There's a procedural science activity kind of going on there, but at the same time, that's a lot of work to do and very difficult. So if we go to quests, editor, we can edit an existing quest, and I'll do Pond Trap as an example. So within a given quest, I can go into the stages of that quest. I can edit a stage, and in this case, I'll edit stage 2. And we have some things that they have to do. In this case, the stage 2, they have to get to within 5 blocks of the liquid sensor, which is a location on the map. But we can also do a custom objective. Maybe we want them to get to the liquid sensor, but also take down some information. Maybe they would check the humidity at that location. So we're going to go ahead and do a custom objective, number 8 there. And you notice that we have this science tool objective. So I can say science tool objective and enter the number of measurements the player must take with the tool. So we only want 1. So we've selected that they need to use the science tool to take a measurement, but we also have to tell it which science tool specifically to use. So once we've got that science tool objective, we say 1, we're going to use the science tool, and we have to enter the value for the science tool. So there we go. That should be hopefully the correct value that they would use. We are in testing on Trappist, and they're to go to the pond to take a measurement. So if we look at the quest here, there are several planets in the habitable zone. Unfortunately, they do not have much liquid water on their surfaces due to elevated levels of high energy radiation emitted by the host star. What do you think those pools of liquids could be? Let's go investigate to find out. Now, humidity is probably not actually what you'd want to use to do this, but you get the general idea, right? So I've gone to find one of these ponds, which I could find on the map. And here now I get to it. I've gotten to the liquid sensor. So I've successfully done that. And it says measure humidity 0 of 1. So I should be able to type /humidity now. And there we go. It gives me credit for measuring the humidity, and it tells me the humidity is 54%. So I've now completed that element of the quest. So that is now one of the things you can do with the WHIMC Science Tools plugin. Once again, just a reminder that you can find all the information on the Science Tools plugin here on our GitHub, where you can see the latest updates and changes we make. So here, I've got added night and weather clear. You can download this, compile your own version, make suggestions for us to change it. There's also this great Readme file that gives information about how it all works. And you can go ahead and help us out with this project. Once again, thank you for checking this out. We're very excited to bring you new opportunities and elements in our game.